It is common to receive requests for locating receptacles in the back of bathroom vanity drawers. Interior designers and homeowners often request this for convenience and aesthetics. The typical installation method involves several steps. Firstly, drill a small hole in the back panel of the drawer, making it large enough to accommodate the receptacle. Secondly, insert a ground fault circuit interrupter receptacle into the hole and secure it with screws. Thirdly, run electrical wiring from the receptacle to the electrical panel or an existing power source. Fourthly, install a cover plate over the receptacle to provide a finished look. When considering this type of installation, there are several factors to keep in mind. Firstly, ensure compliance with local electrical codes and regulations. Receptacles must be ground fault circuit interrupter protected in bathroom areas. Secondly, ensure that the drawer has sufficient clearance to open and close without interference from the receptacle or wiring. Thirdly, consider the weight of appliances and ensure that the drawer and receptacle are adequately rated to support them. Fourthly, appliances should be able to dissipate heat properly. Avoid blocking ventilation holes or placing objects directly on top of the receptacle. Fifthly, make sure the receptacle is accessible for plugging and unplugging appliances. Sixthly, choose a receptacle and cover plate that complement the vanity design. In some cases, it may not be possible to install a receptacle in the back of the drawer due to drawer structure or code requirement. Alternative options include firstly, installing a pop-up receptacle that retracts when not in use. Secondly, using a drawer insert with built-in power outlets. Thirdly, installing a receptacle on the wall adjacent to the vanity accessible from the back of the drawer when open. When installing receptacles in bathroom vanity drawers, adherence to electrical codes is paramount. The National Electrical Code, or NEC, provides comprehensive guidelines to ensure safety and prevent electrical hazards. Article 210 covers branch circuits, which are essential for supplying power to receptacles. Section 210.8 specifically addresses ground fault circuit interrupter protection in bathrooms. All 120 volts, 15 amps and 20 amps receptacles installed in bathrooms must have ground fault circuit interrupter protection. This protection is crucial to prevent electric shock, especially in damp or wet environments. A ground fault circuit interrupter constantly monitors the current flowing through a circuit. If it detects an imbalance, indicating that current is leaking to ground, it quickly trips the circuit, cutting off power and preventing a potential shock. The NEC mandates ground fault circuit interrupter protection not only for receptacles near sinks but also for those within a certain distance of water sources. This requirement ensures that even if an appliance is accidentally dropped into water, the ground fault circuit interrupter will immediately shut off the power, minimizing the risk of injury. In addition to ground fault circuit interrupter protection, the NEC also addresses the placement and accessibility of receptacles. Section 210.52 specifies the spacing requirements for receptacles in dwelling units, including bathrooms. While this section primarily focuses on wall receptacles, its principles can be applied to receptacles installed in vanity drawers. The goal is to ensure that receptacles are conveniently located and readily accessible for plugging in appliances. When installing a receptacle in a vanity drawer, it's important to consider the drawer's construction and available space. The receptacle must be securely mounted and protected from physical damage. The wiring must be properly insulated and routed to prevent chafing or abrasion. It's also essential to ensure that the receptacle does not interfere with the drawer's smooth operation. The NEC also addresses the type of wiring methods that are permitted for use in electrical installations. Chapter 3 outlines the various wiring methods, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and non-metallic sheath cable. The choice of wiring method depends on the specific application and environmental conditions. In a bathroom setting, it's important to use wiring methods that are resistant to moisture and corrosion. Proper grounding is another critical aspect of electrical safety. The NEC requires that all electrical equipment be properly grounded to provide a safe path for fault current to flow back to the source. Grounding helps to prevent electric shock and minimize the risk of fire. When installing a receptacle in a vanity drawer, it's important to connect the receptacle's grounding terminal to the building's grounding system. This can be achieved by running a grounding conductor from the receptacle to a nearby grounded metal box or to the main grounding electrode system. Furthermore, the NEC provides guidelines for selecting the appropriate size of conductors for electrical circuits. Section 310.15 specifies the ampacity of conductors based on their size, insulation type, and ambient temperature. It's important to choose conductors that are large enough to carry the intended load without overheating. Overheated conductors can lead to insulation breakdown, short circuits, and fires. In addition to the NEC, local electrical codes and regulations may also apply to receptacle installations in bathroom vanity drawers. These local codes may have additional requirements or restrictions that must be followed. It's important to consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. When planning the installation, consider the types of appliances that will be used with the receptacle. High-power appliances, such as hair dryers and curling irons, require a dedicated circuit to prevent overloading. The NEC specifies the maximum number of receptacles that can be connected to a single circuit based on the circuit's amperage rating. It's important to avoid overloading circuits, as this can lead to overheating, nuisance tripping of circuit breakers, and potentially dangerous situations. Before starting any electrical work, it's essential to disconnect the power to the circuit. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It's also important to verify that the power is off by using a voltage tester. Working on live electrical circuits is extremely dangerous and can result in serious injury or death. When working with electrical wiring, it's important to use the proper tools and equipment. Wire strippers, pliers, screwdrivers, and voltage testers are essential tools for any electrical project. It's also important to wear appropriate personal protective equipment, such as safety glasses and gloves, to protect against electrical shock and other hazards. After completing the installation, it's important to test the receptacle to ensure that it is working properly. This can be done by using our receptacle tester, which checks for proper wiring and grounding. If the receptacle is not working correctly, it's important to troubleshoot the problem and make any necessary corrections. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you are not comfortable performing the work yourself. A licensed electrician has the knowledge, skills, and experience to safely and correctly install receptacles in bathroom vanity drawers, ensuring compliance with all applicable codes and regulations. The location of the new receptacle in a bathroom vanity drawer presents unique challenges in maintaining safety and code compliance. The presence of water and the confined space necessitate careful planning and execution. One primary concern is ground fault circuit interrupter protection, as previously mentioned. This is non-negotiable in bathroom settings, where the risk of electrical shock is elevated. The receptacle must be ground fault circuit interrupter protected to immediately cut off power in the event of a ground fault, preventing potential electrocution. The physical installation requires careful attention to detail. The hold rolls in the back of the drawer must be properly sized and positioned to accommodate the receptacle without compromising the drawer's structural integrity. Securing the receptacle involves using appropriate screws and ensuring a snug fit to prevent movement or loosening over time. The wiring from the receptacle to the power source must be executed with precision. Using the correct gauge of wire is crucial to handle the electrical load safely. The wiring must be properly insulated and protected from abrasion or damage within the drawer. Securing the wiring with appropriate clamps or fasteners prevents it from being pinched or snagged when the drawer is opened and closed. Clearance within the drawer is another critical factor. The receptacle and wiring must be positioned so they don't interfere with the drawer's contents or its smooth operation. Adequate space must be maintained around the receptacle for proper heat dissipation to prevent overheating. The choice of receptacle and cover plate should complement the vanity's design while also meeting safety standards. A tamper-resistant receptacle is recommended to prevent children from inserting objects into the slots. The cover plate should be securely attached and made of durable material. Alternative methods offer solutions when a standard receptacle installation isn't feasible. Pop-up receptacles provide a sleek, space-saving option that retracts when not in use. Drawer inserts with built-in power outlets offer a pre-wired, integrated solution that simplifies installation. A wall-mounted receptacle near the vanity provides convenient access without requiring modification to the drawer itself. When considering appliance safety, it's essential to assess the weight and power requirements of the devices that will be plugged into the receptacle. The drawer and receptacle must be adequately rated to support the combined weight of the appliances. Overloading the receptacle can lead to overheating and potential fire hazards. Heat dissipation is a key consideration, especially for appliances that generate heat, such as hairdryers and curling irons. The receptacle should be positioned to allow for adequate airflow and prevent the buildup of heat within the drawer. Avoiding blocking ventilation holes or placing objects directly on top of the receptacle is crucial for safety. Accessibility is another important factor. The receptacle should be easily accessible for plugging and unplugging appliances. Consider the placement of the receptacle within the drawer to ensure it's convenient to reach. The overall aesthetics of the installation should blend seamlessly with the vanity's design. Choosing a receptacle and cover plate that complement the vanity's style enhances the overall look of the bathroom. Hiding the wiring and receptacle as much as possible contributes to a clean, uncluttered appearance. Local electrical codes and regulations play a crucial role in ensuring a safe and compliant installation. Consulting with a qualified electrician is essential to understand and adhere to these codes. Obtaining the necessary permits and inspections ensures that the installation meets all safety requirements. The National Electrical Code Article 314 covers outlet boxes, conduit bodies, and handle enclosures. While the installation in a drawer isn't a typical outlet box situation, the principles of protecting conductors and making secure connections still apply. The receptacle itself must be listed and suitable for the intended use. Article 406 covers receptacles, cord connectors, and attachment plugs, including requirements for ratings, grounding, and tamper resistance. For wiring methods, Article 300 provides general requirements for wiring, including proper support, protection from physical damage, and securing of conductors. Depending on the specific installation, you might use non-metallic sheath cable, flexible metal conduit, or other approved wiring methods. The choice depends on factors like the drawer's construction, the level of protection needed, and local code requirements. Grounding is critical as mentioned before. The receptacle's grounding terminal must be connected to the equipment grounding conductor of the circuit. This ensures a path for fault current to flow back to the source, tripping the circuit breaker and preventing electric shock. The NEC also specifies requirements for the size and type of grounding conductors. When dealing with appliances that generate heat, consider Article 400, which covers flexible cords and cables. If you are using a cord to connect the receptacle to the power source, make sure it's of the proper type and rating for the intended use. Also, ensure that the cord is protected from physical damage and is not subjected to excessive strain. The location of the receptacle within the drawer also raises concerns about accessibility for inspection and maintenance. While the NEC doesn't specifically address receptacles inside drawers, the general principle of accessibility for electrical equipment applies. Ensure that the receptacle can be accessed without undue difficulty for future inspection, testing, or replacement. Finally, remember that electrical work can be dangerous. If you're not comfortable working with electricity, it's always best to hire a qualified electrician. A professional electrician will have the knowledge, skills, and tools to perform the installation safely and in accordance with all applicable codes and regulations. Remember, Logan, Utah may have specific requirements.